But to start off our day, we have a problem of the day. So let's see what we've got going there. It says, what positive integers from 1 to 100 inclusive? That means you get to include 1 and 100, folks, are both perfect squares and perfect cubes. Now you say, Ernie, what's a perfect square? It's like 3 to the second power. 3 times 3 gives you 9. So that's a perfect square. Now if I wanted to make a perfect cube, 3 times 3 times 3, which will give us 27, that's a perfect cube. All right, that's what we consider those things. So what we're looking here is where do these positive integers from 1 to 100, all right, where do they have both in common? Well, I can tell you one that's really pretty easy. Let's just talk about them here. First of all, let's look at squares. First of all, are we going to go all the way from 1 to 100? Well, we're going to go a good bit. Why not? But we've got 1. There would be 4 because that's what 2 squared is. You got 3 squared, which gives you 9, 16, goodness, 25. Keep going, 36, 49. Got another one? Oh, that was 7 squared, by the way. Some of you are going, well, where did you get that? 8 times 8, which would be 64. Then we got 9 times 9, which gets us to 81. And you know what we said? We could go all the way to 100. So here we go. That's 10 squared. So those are the perfect squares. Now the question is, which of these are also perfect cubes? Well, first of all, let's talk about it. 1 to the third power is not 3. I know some of you say, well, that doesn't work for us. Yeah, so there is one of those examples. So we put that inclusive in there. Hey, maybe 100 does it? We'll find out. 4, definitely there's nothing that you can, well, it's kind of a crazy. The cube root of 4 doesn't come out to anything that we want to look at. It's certainly not a perfect cube. Neither is 9, 16. Wow, 25, you almost think it should be, but it doesn't quite get there. 49, it was 7 times 7. Those are prime numbers to begin with, so there are not going to be any perfect cubes coming out of that. Here is where we have a little bit of a fun moment. What about it? We have done, let's just go ahead and put what they are. 2 to the third gave us 8. So this is somewhere between 4 and 9, actually closer than 9, right? And then our next one was 3 to the third. That was the next perfect cube, which would be 27. So, you know, there's a couple of ways to look at this thing. First of all, look at where the numbers are, and this one's closer to 25, obviously. So what's the next one? 4 times 4 is 16 times another 4 is going to give us 64. There is another match. I got news for you. 81. Oh man, it's easy to try to say 3, but you know what? 3 to the third power gives us 27. 3 to the fourth will give you 81, but that's not what we're looking for. So I guess that'd be a perfect fourth or something like that. And 100, oh, it's kind of tempting to do that because, oh, isn't that 10? But 10 times 10 is 100, times another one would give you 1,000. So 10 to the third gets you up to 1,000. These are your only little hope right there for them to overlap each other. Now, why do we ask things about perfect squares and perfect cubes and things like that? Well, let's talk just a little bit here. You remember your good old friend, the Pythagorean theorem. I'm just going to go off base just a little bit here. The a squared plus b squared equals to c squared. I'm going to use some triple moments, all right? And by the way, for those of you getting ready to take ACTs, if you understand what a triple means, in other words, those are integral values that will work out, kind of like a family that works together. You say, what do you mean works together? That always will give you another integer. For example, let's use an easy one here. How about it? 3 squared plus 4 squared. And the question is, what would be our c squared out there, all right? And if they'll lower my lower third just a little bit for me, that'd be nice. There we go. That's going to give me 6. No, it's not going to give me 6. What is that? That's going to give us 9, right? That's why we want to know. I was checking to see if you guys are with me. 9 plus, how about it? 16. That's what 4 squared will give you. And we're going to try to figure out what c squared or exactly what c is. And we add those two together. It's really nice. You get 25, and that is equal to c squared. Aha, c is 5. It's nice to know the perfect squares. Nice to know your perfect squares there. And again, up through 100, I suggest you go all the way up through 400. There are quite a few good numbers there. And you learn these in your times multiplication fact, your times tables, we like to call them. And, you know, so it's not that hard to do. It's not that hard to figure out, not hard to remember. Now let's talk about the other side of things. What if I have a cube, a real physical cube, like a box, all right, where all the sides, all 3 dimensions are the same, and we're looking for the volume of that cube? It's very easy. If you can come along and say, oh, that's 3 meters for all 3 dimensions, 3 times 3 times 3, you would have 27 cubic meters. Now, if we were looking at an area of a square, that would be 3 times 3, which would be 9 square meters. So perfect squares, perfect cubes, they are important. And I'll tell you what, when you start taking those ACT tests, which are timed, and you've got 60 questions due in 60 minutes, yes, folks, to get into college, that's what we all take, the ACT around this area. Those, you need to know a few things off the top of your head. So a little bit of a plug for that. ACT, SAT, the same way. Those are timed tests, and you just don't have enough time a lot of times because they expect you to know a few facts independent of just how to do the problems. And that's your problem of the day as we look at it there. So